Okay, just going to go through an example for exercise 11c of the Pearson Applied 1 textbook. Basically, this is using differentiation and variable acceleration to solve maximum and minimum problems. So some optimization type problems. So a child is playing with a yo-yo. The yo-yo leaves the child's hand at t equals 0, travels vertically downwards before returning to the child's hand. The distance in meters s of the yo-yo from the child's hand after t seconds is given by this formula. It's valid for when t is between 0 and 3. So first of all, we need to justify that restriction between 0 and 3. And then we need to find the maximum distance from the child's hand. So it's a maximization problem to 3 significant figures. So first of all, we need to justify this restriction. So if you look at the formula itself, and we sketch a graph of it. So if we're going to sketch a graph, first of all, the y-intercept is obviously going to be 0, because when t equals 0, the displacement will be 0. And then we need to solve to find the roots. So first of all, we set it equal to 0 and solve it by factorising, and you get t equals -1 or t equals 3. Okay, so we know our roots. We know it's a negative cubic because the cube term is negative. So if we sketch it, it's going to look something like this. Okay, so we know it leaves his hand when t equals 0. And because we're talking about the displacement downwards, we know that the displacement is always going to be positive. Okay, otherwise the yo-yo is gone above his hand. So therefore we can say that the justification between 0 and 3 seconds is justified because the yo-yo will never go above his hand. Okay, so that's why it's between 0 and 3. Okay, next one, to find the maximum distance from his hand. This is where we're going to use our differentiation. So we need to find the maximum point here, and we do that by finding the velocity. And obviously when it's its maximum distance, the velocity is going to be 0. So if we start off with our displacement formula and differentiate it and set it equal to 0, then we can work out value of t. So just solve that equation using your calculator, and you get these two answers. Obviously we don't want two answers, we just want the one. We can't travel back in time, so we can't use a negative value of t. Also, we know t is between 0 and 3 seconds, so we need to take the 1.868 value. Okay, so we know the time when it's at the maximum distance. Now we need to find out what that distance is. So we've got that value, that's a rounded value. So we want to keep that exact value. So use the answer button on your calculator and just sub that into your original displacement formula, and you'll get 1.21 meters for the maximum distance. Okay, so these questions are, the most challenging thing about them is trying to figure out what the question's asking you, using words to give explanations. Draw sketches always helps. Okay, so go away and have a go at a few questions, please.